What's up, Sensation? My audio's working this time. Yeah, I think it is.
What are you doing to me? It's too early.
What are you doing today? It's too early. What time is it over there? Time in the UK. What time is it? Time in the
It is
UK.
2300 hours.
2300 hours, he says.
And
Oh, 11
echoing back
p.m.
to myself?
11 p.m. That's not too bad. That's pretty early. It's kind of like my peak wake-up time, honestly, like 11 p.m. Or my peak productivity time is what I say.
Why am I echoing back to myself?
I know why. It's because Discord made this dumb thing wherever you share a screen, it defaults to sharing the audio. There you go. Now it's fixed. Thank you for Thank you for telling me that, though. Yeah. Discord. I don't know why Discord did this, dude. It made everything so bad. Oh, yo, what's up, Patty? I haven't seen Patty in a minute, dude. Come up, say hi if you want.
Yo, what up?
Patty G. What's going on, dog?
Going?
Good.
I'm good.
You're good. Good. Are you?
Yeah,
I forget. You're from Chicago, right? Yeah. So are you a Lions fan with all this Detroit
Am I
stuff
a
going on?
Lions fan?
Yeah.
Yeah. I mean, I'm rooting for the Lions. I mean, they're the underdogs, right?
Yeah. Fuck the Niners, dude.
Yeah.
Although, yeah, that's what they play next, right? The Niners.
Yeah, they play Niners. Ravens play the Chiefs.
Ravens are gonna absolutely decimate the Chiefs.
Unless the NFL is rigged for Taylor Swift.
Right? Yeah. She does sell a lot of tickets. You know, that's a good point.
She does. She's good for business, but
she's great for business. Oh man. Yeah. I did like all the pictures of Jason Kelsey just with his shirt off, just like raging up there.
That's dope.
Yeah. I'm just like,
those were funny.
I'm
Yeah.
like, bro, that's me. That's me. What's up, Hypatia? Good to see you.
Did you get any chance to talking or just looking at the solution?
Oh, to that one with the series stuff and whatnot.
Yeah, it has been 1 week old, but I'm sorry.
No, it's good. No, don't worry. No. No such thing as one. Yeah, no, that's fine. Yeah, I looked at it, but yeah, maybe I can go over it later today. I got to do a couple kids' questions before they leave. And then I'm glad you were talking with Penn Center. Penn Center's great.
Whose question was it?
Whose question was the question from last week? That was Teacups.
Oh.
It was a fancy calculus question, is what it was. Yeah.
If you are on that analysis class 2 next time, you can post this thing as well. I think it's fun.
Oh yeah, dude. I like. Did you go to the E to the Pi I's? What is it, Zach's? Did you go to his real analysis class? His real analysis class is pretty
Yeah,
fun.
well, I sometimes will have pedagogical disagreement with the way, like, I want to stress on the logic and foundation part as well as the analysis. Otherwise, like in the future, if they want to study analysis or want to do research in analysis or dynamics, they will inevitably encounter foundation issues.
Exactly. No, I got you. Yeah, you got to set a good base for what you're doing. Otherwise, things start kind of messing up later down the road. Totally. All right, here. Let me kick off the stream. I'll do because I know a couple kids got questions and they have to leave, and then we'll go into all the fun stuff. All right, cool. All right, welcome everyone to Office Hours. My name is Dr. Gold, Actual Education, stream of healthy health, math homework, science homework, all types of fun stuff. What was this? Oh my God, this was this was Ethan's question earlier. Okay, now let's get away from this. That's way too much geometry. All right, cool. Bob, I know you got to go soon, so let me work through yours. For what values of A and B is the following equation true? Ooh, uh-oh. Got some limits going on here, right? Sine of 2x over x cubed, b over x squared, a and okay. Let's maybe like combine these all to be the same denominator. That's just like kind of my first guess here, right? Because I got x cubed, I got x squared, and I got nothing on the bottom here. So let's go let sine 2x over. I think this is gonna be like a sine of x over x thing. What is this? Ax cubed over x cubed, and then this is plus bx over x cubed is equal to 0. And okay, for what values is the limit of this as x goes to 0? Okay, well I think I can get. Can I multiply through by x cubed? Is that okay? Am I allowed to do that? Can I do that, Hypatia? Am I allowed to do that? Can I just like multiply by x cubed, just get rid of all these?
Oh wait, probably not.
Wait, what? What's you talking about?
This question right here. Yeah, so I put them all under the same denominator. It's technically the limit as x goes to 0. So I know you're not allowed to divide by 0, but can I multiply everything through by x cubed just to like get rid of all these?
Wait. So what are you trying to do? I mean,
Well, we're trying to show that this limit goes to 0
Okay.
for certain values of a and b, and all I'm doing is combining them with the same denominators, and then I'm getting rid of the denominator.
so you want to do wait.
I think I'm allowed to do that. I don't know.
Let me see.
Someone who's a math authority, I'd say like a math police officer would tell me like, no, you can't do that, because there's certain rules with limits and going to 0 and whatnot of what you're allowed to do.
I don't think you can do it. So like in essence, you are
What's up, Demarcus?
saying, like you want to put a limit of as x goes to 0 of x cubed on
Yeah.
the both side of the equation, but that thing is also 0. So that
Right.
that just doesn't make the equation
Doesn't make it
give
any
any
nicer.
sense anymore.
Uh-oh. Okay.
Wait, let me see how I can do this.
I think this is a sine of x over x thing. I think this is what this is eventually gonna be. Let me just try and figure it out. Bob, was this a question in your calc class? Really?
Homework question.
Really? Damn.
Yeah.
Okay. Yeah.
Sin x over x is 0.
Right? Yeah, I
As
know
it
that.
goes to- No, it's 1 as it goes to 0.
Oh, it's 1 as x goes
Yeah.
to 0. And then this is sine of 2x, which I
So
remember.
you multiply 2x on both sides. You multiply the top and bottom by 2x. You can take out the sine 2x.
Exactly. Yeah. So, yeah. So I can take this. You could do a u substitution, or you can do this. You're right. I can say it's 2x, sine of 2x, what, over 2x, and then this is x cubed. And then
Yeah.
I know that
That just
this
goes to
this goes to 1. Okay, cool. So then I have 2 over x squared plus a plus b over x squared, right? Is equal to 0.
Yeah.
Ooh. Okay. Now I kind of want to like put these under the same denominator.
Okay, I mean, you can just give make all the 3 terms in the sum having the same denominator, and then add them together into a big fraction, and then try to
Yes.
analyze one the numerator grows decreases.
I think it's
faster
this.
than
I
the
think it's this.
denominator.
I think it's this, right? Yeah. So once I've assumed that this thing is 1, yes, because right, limit as x approaches 0 of sine of x over x is equal to 1. Cool. I can get rid of this. Then I'm left with 2x over x cubed, which is 2 over x squared.
I mean, that's not quite as rigorous, but
Does it
well,
work though? Is it legal?
Like-
Or like, is this legal?
No, it's called I talk about this all the time. It's called equivalent infinitesimal. It's a trick.
Mhm.
You want to not write in terms of tricks or not write a proof in it's based on you are cutting off a Taylor series, but
Yes. Yeah.
yeah, like the thing is that trick. Just write the proof properly. Like a lot of Chinese students use that because it's something from a Soviet textbook that just
Right.
got spreaded everywhere.
Okay, but if I have like ax squared plus b plus 2 is equal to 0, aren't there like a ton of solutions here for a and b? Oh, wait, but x goes to 0. So can a be whatever? A equals like all real numbers, and b is equal to -2. Is that a solution?
Sine 2x.
I could also, like-
and
I could also check this. We love check. Damn, it is pouring today. What's up? What's up, Ethan?
plus ax is 3 plus
Not yet.
bx, and then you can do.
I just woke up like an hour ago.
Oh, I mean, you can just put it in that big fraction form and then use L'Hopital's rule, I guess.
Oh, you are right. Oh, L'Hopital's rule. Oh, we
Oh, look,
forgot.
yeah.
Why don't you do that?
I like that. I like that. I think we can do this, right? Can't we do L'Hopital's rule here? Because it isn't 0 over 0 though. This doesn't become 0 over 0. This
It's
becomes
not?
b over. The top becomes b plus 2 over 0.
Oh, in which case, if you do 1x2 plus not like if the b is not a 0, then the thing is wait.
Yeah, I need the b to be -2. I think I have to have the b be equal to -2. Right?
2 plus 2. Yeah, that's one case. And then is there?
Oh, but
any
then
other case?
but wait. If b is -2 and then we do L'Hopital's rule, this is going to become a over 1. Is what the limit will go to, which is not 0. So now I need b to equal -2 and a to equal 0, technically.
That's one case. Like
Yeah.
you need to see if there's any other case where this can. So say if a is non-zero, can you do anything that's?
I don't think so because right, the premise for L'Hopital's rule is I need 0 over 0 before I'm allowed to start taking derivatives, I think, right?
Yeah, but I'm saying that is this the unique answer to this? Like it asks for which values
Yeah.
of a and b. So let's see if this is the unique case where it gets that.
This is such an interesting question, Bob. For a calc class. like,
Well,
what?
well, I mean, if wait, this one has to be 0. This one decreases.
Da-da-da. Wow, they say a is equal to 4/3? What? Excuse me? Excuse me. What an interesting solution.
Yeah, I think this is the unique. This is the unique value for which that thing is 0. I think.
Wow.
But how do I prove it?
1 sec here, I'll pull it up.
不知道.
What the fuck you say, Sensation? What did you just say?
Ask Hypatia.
Oh, is this something in
I
Chinese?
think they're saying that they don't know either. I think so.
Is my pronunciation that bad? Oh well, I'll practice more.
Yeah. No. Okay, so we don't want to do sine of x over x. Yeah. We wanted to do it the original way I was doing it. This is what it was. Sorry, my bad. So first have everything right under the same fraction, Bob. Okay. So that's sine of 2x plus ax cubed plus bx all over x cubed, right?
Yeah.
Okay. Now, yeah, don't do the sine of x over x yet. Now, as x approaches 0, I get 0 over 0. So I'm allowed to use L'Hopital's. Good. Yeah. So then this is cosine of 2x times 2, right? Plus 3a. My voice is cracking. X squared plus b, right? All over 3x squared. Which, okay, now this is 1. This is, over 0, so I don't like this already.
It's 2 plus something. 2 plus 0 plus b.
Wait, 1 sec. 3ax squared plus bx. I agree with that. Yeah, cosine of 2x times 2. But then, this tells me b has to be equal to -2. In order for me to go down L'Hopital's rule again, right? B must equal -2. Because this is gonna this is gonna turn into 1, right, Bob? And then 1 times 2. Yeah, okay. So assume B is equal to -2. All right, then we go down one more path. And then that gets me -4 sine of 2x, right?
Yeah.
Plus 6ax over 6x. We're still good. 0 over 0, 0, right? Do one more, and then now we get -8 cosine of 2x plus 6a over 6, right? Equal to 0. Yeah, good. And this goes to 1. So I get -8 plus 6a is equal to 0. Cool. A is equal to 4/3. Yeah, and then you're done. Wow. Okay.
Oh, I see.
That's cool.
Tricky.
That is tricky and cheeky. It is both of those things.
You know that problem that you did? Yeah, you helped me with like last week.
Yes.
I asked her about it today. I went to her office hours and she couldn't do it.
Which one was that? Let me see. I probably have it from
It
somewhere.
was like that one. She
This-
couldn't do this one.
Oh, yeah.
She was
Doing
like-
this.
She said it's already simplified.
Ah! Wrong. Oh my god, dude.
And then she looked at the answer key.
Oh my god. And then she's like, "Oh wait, yeah, I'm actually wrong." She should know how to
Yeah.
do this. I mean, the tricky thing was this: the double angle was. This is what was tricky. It was tricky
Yeah.
having to do the double angle. But yeah.
Obviously, she knew her double angle identities. That's why.
Yeah. Obama says my teacher wasn't in class and I got no clue how to do my homework. I'm cooked. Well, thankfully you came to the right place. Let's uncook you for homework. Yeah. Good job,
Thank
Bob. Yeah, I appreciate that. Yeah, you're good, man. Bob had a good question. I liked Bob's. Let me see. Patty, I'll do yours because I know you haven't asked a question in a while.
Yerp.
Europe. Obama says I'm lazy, bro. What? Just.
When am I getting my turn?
You will get your turn, Ethan. Don't worry. I have to. We gotta be fair for everyone that's asking questions. Ethan's on a 35 stream watch streak. Wow, dude. A push. Oh yeah, you guys call this AP US history. You call it A push. We used to call it just AP US. You guys call it A push. It's kind of weird. And AP Lang, dude. AP Lang's whatever, dude.
AP Lang was mid.
Mids, definitely mids. Oh, this is cool.
Hated that class.
I was literally doing this question, Patty, with a student at 11 o'clock this morning, and I really didn't want to do this at 11 o'clock this morning. I went to bed right afterwards. I said nope.
No
But it's not
thanks.
too bad. Okay.
Yeah.
This is a continuous function. Okay, that's cool. What do you know about functions being continuous?
Continuous functions. There's no like a limit exists anywhere on the function.
True. Yeah.
Into it?
It means that you never lift your pencil and whatnot, and
Yeah, it's like there's no like stops or like any like holes or
exactly.
Like
And what it means
jumps.
with piecewise functions, because some people don't understand this, like what the hell is this bracket thing? Like, why do I have two functions here? What they're doing is they're saying that this big function, this big like art piece, has two smaller pieces that make it up. In this case, they're saying, oh, it's x squared plus bx when x is less than 5. So that probably looks, I don't know, something like this, right? That's what this part is. And that stops at 5. And then it looks like 5 sine of whatever pi over 2 x. Oh, thank you, Obama, for the sub. Post your homework, Obama. Post your homework, dude. Let me help you with it. And then, yeah, it looks like sine of x. It looks, I don't know, something like this. That's what it means for this to be a piecewise function. In order for this to be continuous, what I need, Patty, is I need whatever value this function is when it gets close to 5 has to be the same as whatever value
Same as-
this function
So,
is as it gets
I'm
close to
assuming
5.
you set it equal to each other.
Yeah, exactly. Yeah, good. Yeah. What you do is you
I-
set this equal to this at 5.
Mm-hmm.
All right, so we have x squared plus bx is equal to 5 sine of pi over 2x, and then I just plug in 5 for x, okay? Because that's the boundary point. That's where they switch.
So it would be just 5 pi halves and then 5b.
25 plus 5 plus 5b, right? Right, because x is equal to it's
Oh.
x squared.
Yeah.
is equal to 5 sine of 5 pi over 2, right? Okay. Yeah, and then you just solve for b. This is easy. 5b is equal to 5 sine of 5 pi over 2 minus 25. Okay. Do you know what sine of 5 pi over 2 is?
Sine of 5 pi over 2.
Mhm.
5 pi halves. My unit circle is really rough.
No. 5 pi over 2 isn't going to be on a unit circle because first of all, it goes over 2 pi.
Yeah, I don't. Yeah, I was
Right.
gonna say. I
What
don't think it's-
what would be 2 pi halves? How many halves do I need to get to 2 pi? You know,
How many halves? You need 2 halves to get to
no, you need 4. You
Wait,
need 4
2 pi?
halves. You need 4 halves to get to 2 pi.
halves.
Yeah, right.
Oh,
4
wait.
4 times pi
Yeah.
over 2 is equal to 2 pi, right? Love that.
Yeah.
So you have 5 of them, right? You have 5 halves. So you're going around
Yeah, so it's
once.
Slightly over 2 pi. Yeah.
Right, and then you're just going another half. And I know I hated the unit circle too until I just figured out a way to learn it, and it wasn't memorizing. But you're here, right? This is pi over 2, which is the same thing as 5 pi over 2.
Mm-hmm.
Sine is opposite over hypotenuse, right?
Mm-hmm.
If this were, what is this? If this no, stop that. If this why can't I just want to go there? If this is like going like this, right? The opposite is always
Yeah.
this side, right?
Mm-hmm. Yeah.
What does that opposite go to once we hit like this angle?
Well, not there.
It goes to basically 1, right? Because this is a unit circle, right? Which means that the radius
Oh, well,
anywhere
yeah,
is equal to
at the
1,
very end, it's 1. Yeah.
right? So once this thing hits there, now the opposite, right, becomes the
Is
same
1.
as the hypotenuse. That's why this is 1. Yeah, good. So this is right. 5b is equal to 5 times 1 minus 25. Good. What's up, teacup? What is this? B is equal to 1 minus 5. So it should be equal to -4. So I think is that one of your answer choices? Yeah, it's choice C.
Yep.
Nice. There you go. Does that make a little bit more sense?
Yeah. So since 2 pi is like 4 pi over 2, right? So 5
Yeah.
pi over 2 is more than that.
Yes,
It's just adding another half, so that's why it's equal to 1. It's like
exactly.
or vertical.
It's vertical. It's vertical. Now, what would happen? So they asked for where is it continuous. The next question they could ask is where is it differentiable. Okay.
Differentiable.
Yeah,
Okay.
I'm gonna just show you just real quick because it's the next step they ask you here. So they'll ask, how do I make it continuous? Right? Just make these two things equal to each other at the boundary, like we did here. In order for it to be differentiable, you need the derivatives to also equal the same value at this boundary.
Yeah.
Okay.
Mhm.
So if you want it to be differentiable, now all you do is you say, okay, where does 2x plus b equal to, what is this? This is going to be 5 pi over 2 cosine of pi over 2x. All I did is I took the derivative of this, right? And then I took the derivative of this
Yeah, and then they have to equal the same
at 5.
for example, 5. Yeah.
Exactly. Yeah, and then you just plug it back in. And well, this actually this may not work actually. Well, no, it will work. Because cosine of 5 pi over 2, this is going to be
It's
0.
just 1.
No, that's 0. Remember, so sine was the opposite, right? Look what happens. Cosine is adjacent.
Oh wait, because cosine is it doesn't go anywhere. 'Cause it's
Right.
vertical,
So yeah, once we're
so it's
vertical,
0.
cosine is 0. Right, yeah. So this goes to 0. And then you
Yeah,
have
so
10
we're
plus b is equal to 0. So what does
Yeah,
b
so
have to
b
be?
is 10.
B is negative 10, right? So
Yeah.
this is interesting. This function can never be differentiable. Because here's a requirement. In order for something to be differentiable, it has to also be continuous. Yeah, it has to be
So
like
it's continuous, but it's not differentiable.
it's not differentiable. It can't be differentiable. Yeah, exactly. Because the only way it can be differentiable is if b is equal to negative 10. But if b equals negative 10, then it's not continuous. And it's just like, okay, well now it's not differentiable. So I don't know. It'd be a cool little bonus question. Nice.
Yeah.
Good job, Patty. Anything else like bothering you in class? That's good.
I mean, It's all right now. We were just going over, so we just went over like natural log, like we went over the properties real quick, and then we
Mm-hmm.
started differentiating them and integrating them. And then for some reason our teacher's been out for the past couple days,
Oh
so
no.
we've had the other calculus teacher as our teacher.
Okay.
Because
Is
he
that
has
the
like a
one
free
Philip
block
has?
during our block.
Is that the one Philip has?
No.
Oh, okay.
No, we have the other calculus AB teacher. We have two of them. And he like assigned us like just a little extra homework because like our teacher didn't give us any over the weekend, so that's
Okay.
the thing I'm doing right now. It's like pretty much like AP review. It's like straight from the samples.
Yeah. Okay. Cool. Yeah. It looks pretty. It's pretty basic stuff. But yeah, if you ever have questions with it, just throw them in. I'll help you out with it.
Hmm. Are
Cool.
you in here for an hour, right?
I'll be here for at least an hour and a half. Yeah. So if you have more questions, yeah, if you want to work on whatever you're doing with homework, and then just post them, I'll get to them as soon as I get through everyone else's.
Okay.
I'll be here.
Well, I gotta leave for practice in like a half hour, so
Okay.
I'm gonna try and work through some of these, but
Cool. Do it. If you ever have other things, you
Alright.
can always just drop them in the screenshots channel. If I have like time in my off whatever hours, I sometimes just answer them.
okay. And then do you post them in the
Mhm.
channel as well?
I'll tag you. Yeah, if you post something you need help, I'll tag you and I'll post what the solution is.
Okay, cool.
So yeah, feel free to just like if you're having to go to practice, you're like I don't know how to do this one, just drop it in the screenshots channel, and if I get it done later, I'll tag it and post it to you.
All right, cool.
Cool, dope, dude.
Appreciate it.
You're welcome. All right, Ethan, let's do your question. What's up, Ethan?
Here. Hey, Dr. Go.
What's up?
Have you ever seen my the good grades? I posted something in
I
there.
haven't yet. No, I get a gazillion fucking pings in the Discord. Don't worry, I appreciate you posting them. I will get to them, but yeah, I can't
But you
check
know,
everything all the time.
I got my hold on. I got my Java test online
Okay.
in June, and I actually saw my grade.
And how'd you do? Is baby voice working, Obama? Sorry, I had to renew the Twitch token for the Twitch token for Sammy. Sammy wasn't working. Here, I'll redeem it again for you just because. Oh, it's on cooldown. All right, well maybe it's working. I don't know. Obama's just like pouring stuff on. All right, what's up, Ethan? Is this your question we're doing?
Yeah, but I got a 90 on my Java test.
Oh, nice. Good job, Ethan. Love that,
It
dude.
looked pretty easy for sure.
Good. Well, I'm glad you're doing well in your classes. That's the main point of this Discord and this Twitch. Besides buying everyone prizes, I got to give Half Alpha his gift because he won the what was it the podcast.
Wheels.
He won both things actually. I got to give him Nitro too. Yeah. Okay. Here we go. A car is going over a hilltop with a curvature radius R at a speed V. Suddenly, the driver sees an obstacle behind the hilltop and needs to brake. What is the maximal deceleration if the static coefficient of friction is mu s?
Dr. Go.
Okay.
So see, while I was studying physics back in before I went on Christmas vacation, they actually went over some forces, like contact and non-contact forces, and
Yeah.
they even told me about like F is equal. I even told them what I knew about it, like F is equal to ma. So
Yeah.
I really would want to get ahead of that.
Yeah, good. This is good. Yeah, okay. So this has to do with what's called like circular motion. So anytime you
Yeah.
have something
Wait.
that's moving along a curve, Ethan, like this is it's technically it's a hill,
All right.
right? This is going to experience what's called centripetal acceleration. So AC, which has to point inwards. Okay?
Wait, I'm not getting this. Hold on.
Oh wait, your name isn't Taco. Your name is well, Nick, what is your name doing with why is it MMM now and why is it a cat? Y'all, I'm changing your fucking name, dude. What? One sec. I got it. I'm changing his name, dude. Bro, what? Yeah, why? I can't recognize that name, dude. Your name is Nick.
Yeah.
There you go. Now your name.
But now that's changed.
or maybe it doesn't change. I don't know. I'm in streamer mode, so I can't. Whatever, Nick. Yeah. Okay. All right. Anyways, okay. So if something is moving on a curve like this, it's gonna experience an acceleration down towards the center of the radius of curvature is what it is, and this is called a centripetal acceleration, which is equal to the speed v squared over r, where r is the radius of curvature. Okay.
And, could you start back on square one? I didn't get all of them.
Okay. If something is moving in a circle, it's going to experience acceleration towards the center, which is going to be equal to the velocity it's moving at squared divided by the radius of curvature. Radius of curvature refers to this, like how curvy the curve is.
But Dr. Go, he's not even gonna get close to the center of the circle.
He's not. That doesn't matter. It doesn't
So
matter.
how do you-
He's not going to get. He's going to go around. He's never going to get to the center. It's okay. But that acceleration is what keeps him moving around in a circle. Okay. Okay. What is a maximum deceleration? Okay, this is cool. Okay. Because now they're talking about the deceleration in like this direction. This is a weird question, actually. But okay. What we know about friction, right? This is the force of friction, the thing that slows this thing down. What is the force of friction equal to?
Force of friction.
Yeah, what is it?
I think you ever told me that. Hold on, I can search it up. Hold on.
It's okay, and I'll tell you. It's equal to mu k times Fn is what it is. So,
You never told me that. What?
It's-
Wait, what? Upside down H?
yeah. Well, actually, I should make it mu s, actually. That's what I should say. It's technically mu s. Actually, no, it should be mu
What's
k.
mu s?
Why are they saying mu s? It should be mu k. Because isn't the
Trust me,
thing gonna...
Dr. Go, this isn't my class. It's just that I got a free weekend. But yeah, I'm just asking this random question. So
Okay,
I
it's fine.
honestly
It's fine. It's
don't
fine.
know.
Whatever. It's mu is the coefficient of friction. That talks about how like sticky something is. So for instance, like ice has a very low coefficient of friction because it's very slippy. But something like sandpaper or carpet has a very high coefficient of friction, that's what this mu is. This weird mu thing is. Okay.
It doesn't even look like. Wait, how you spell that? How you spell meal?
Mu, 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 it's mu, mu, like a cat. Mew.
Oh.
Yes.
Okay, like
Okay.
these two cats right there, just talking.
You just let him go. It's okay. All right.
But yeah,
Okay, cool. So, this is what we're solving for. Oh, no, we're solving for the maximum deceleration. We'll get to that. So now we got to figure out what the normal force is, all right? For this car, which is right here, okay? Normal force is the force of the ground pushing up on the car, which is being combated by the force of gravity pulling it into the ground.
get it. Yes, we get that. Also, can someone ever change gravity?
No,
Is that not possible?
no, not really on Earth. I mean, if you go to a different planet, force of gravity can
Ben
change.
did, right?
Who did Ben?
Alright.
Wait, who's Ben? Sorry, what? Ben who?
No, I'm saying like you can bend gravity, right?
You can bend the force of gravity, I guess. Yeah, if you're big enough. But
Mm.
yeah,
Honestly, I would like to actually float in on Earth for once. And
yeah. Everything on
so-
Earth is not going to be able to mess with gravity. Okay. Some of the forces has to equal
See,
the mass times the
I'm
acceleration.
wondering.
What?
I'm asking this. Who made that sidewards M, which is the sum of plane?
Sigma. This is the Greeks. I don't know. It's just-
Why
just-
the Greeks again? These
be-
Greeks
It's
must have
always the
been wild.
Greeks.
because the Greeks basically created math, dude. That's why. I mean, technically the Arabs did too. They did some cool shit, but mainly the Greeks.
Yeah.
Was Pythagoras a Greek guy?
He was Greek or Roman, I forget. Probably Greek. I'm not a big,
Alright, well,
not a
that's
huge
fine.
history person. Hi there. What's up? What's up, buddy? First time chat from Anders. Anders, okay. What's up, Anders? Nice to have you. Okay, so some of the forces here. So we have the normal force pointing up. Okay. We have mg pulling down, and this is equal to ma. Now, because this thing is moving around in a circle, the acceleration of this object is going to also
No.
be down, and it's going to be negative v squared over r. Okay?
Oh.
Yo, Eat the Pie, what's up, dude? Hoping to relearn some physics? Well, yeah, good. This is where you came to the right place. We're doing rotational motion.
Also, speaking of physics,
What's up?
I'm still waiting for my physics exam grade.
That's
It just
okay.
determines if I get the A.
Oh yeah, I remember you needed like a 93 or something for it.
Slim chance on that.
Wow, we'll see. Okay, so I can solve here for Fn. I'm gonna just move this over.
Wait, is that the only force?
No, there's the force. There's the normal force of the ground pushing up, and then there's the force of gravity pulling the car down. But the difference between
So
these
all of
two
these-
forces has to be the mass times centripetal acceleration, because this thing is moving around in a circle.
Alright, but Dr. Gold, in all of these questions, there's always going to be like the normal force and the acceleration to the gravity force.
Yes. Yeah. I mean, normal force
Okay,
could be
so that
0,
was-
but yeah, there will almost always. Anytime you have an object resting on another object, there's always a normal force, and that force is always pointing normal, which is a math term for like perpendicular, is what they say, perpendicular to the surface.
But,
Okay.
but then,
Okay, you have Fn. Take this, throw it into here. So now I have that the force of friction is equal to mu s, and then this is times. We can pull an m out of both of these things, 'cause I think the m's are going to cancel. And then this is g
Yeah.
minus v squared over r. Okay. And now what they want to know is they want to know what's the maximal deceleration. So that's how much acceleration, or in this case deceleration, is caused by friction, which the force of friction is also going to be equal to the mass of the car times the acceleration of the car from F equals ma.
alright.
So the cool thing here is now the m's cancel. These go away. Goodbye. And you're left with that A is equal to mu s, and then it's g minus v squared over r.
Where are the variables at?
Well, we're allowed to use those variables because they said they want it just in terms of, it looks like r, v, mu s, g. You're always allowed to use. That's just standard variable.
I'm sorry. I mean, like the numbers. Where are the numbers at?
There are no
Like,
numbers.
there's really no numbers.
There are no numbers. This is a cool thing in physics. A lot of times you'll get questions where there are no numbers, and they just want you to do everything symbolically, which means they want you to do everything just in terms of variables. Where did the mu s come from? Oh, all good. That comes from here, Zach. So the force of friction is always equal to the coefficient of friction times the normal force. This is kind of a weird question because you have centripetal acceleration pulling this thing like down because it's going across a curved like hill, but then you also have what we call like linear acceleration or deceleration in this. Oh, okay. There we go. Stream's back.
New Empire, not Mytonian. Yeah.
Stream
Alright,
should
well,
be back. Should be
That
back.
explains how they come up with that.
I don't know why OBS OBS just decided to stop connecting to Twitch. Excuse me. Anyways, okay, so yeah, he was Greek then, right? Pythagoras was Greek. It sounds like a Greek name.
Yes, New Empire.
New Empire. Yes. Okay, good. All right, so yeah, this is the equation. This is actually cool how this works out, because this is another thing we like to do in physics, where we like to consider limiting cases. Like, does this make sense? So, for instance, if... What's up?
I'm only seeing a blue screen on Discord.
Oh, yeah, sorry, one sec. Yeah, sorry, let me do that. There we go. Okay, there we go. Should be fixed. Okay.
But no,
So-
we got it.
This acceleration we said was pointing in this direction, which is like deceleration, because if it's a positive value, it's having the thing accelerate in this direction. So if the car is moving this way, but the velocity is changing towards this way, it's going to be slowing down. But what we see is that if this coefficient of friction goes up, okay, then the acceleration or the braking acceleration or deceleration goes up. And that makes sense. And where we also see, right, is that if the speed of my car goes up, and I'm trying to brake, then the amount that I can brake is going to go down. So this is always good to like when you have your final equation in physics to look at it and be like, okay, does this like make sense in terms of real life stuff? Yeah. Yeah, no, it's okay. Yeah, OBS crashes sometimes. Anyways. All right. Good job, Ethan. That make more sense? Yeah. Love it. Dun, dun. Nick, your keyboard's fucking clicky as anything, dog. Can you chill?
Oh shit, my bad. I thought I was muted this whole time.
It's okay.
Yo, my bad, bro.
I was like, click, click.
Oh, y'all making me laugh. I can't believe it.
Click, 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 click. All right, let's see. Who else we got? Who else we got for questions? Jamarcus, are you here, Jamarcus? What's up, Jamarcus? The equation mu Fn is talking about the magnitude of the forces. Oh, here, let me answer his question. Sorry. Fr is just it is just talking about the magnitude. So it is interesting in physics. The minus sign thing, we kind of tend to wave our hands at and just say, oh, well, wherever I think I need it to be, that's the positive direction. So when I did this, I assumed that this was like positive and this was negative, which is kind of not exactly correct. Oh, they are intuitively those forces are perpendicular. Yes. Oh, I see what you're saying. Yes, you're right. No, it is the magnitude of them. Yeah, exactly. Why this makes sense? I mean, you can kind of think about, if you're the amount of frictional force that can be provided is related to the amount of normal force that the ground is exerting on the object. This force is always going to be the same, the force of gravity. This will always be equal to mg, okay? This normal force can change based on what other things are happening to this. So, for instance, if you're trying to move a heavy object, sometimes you'll just tell your friend, hey, can you just like try to lift it? Like try to lift this thing off the ground a little bit. What you're doing there is if someone even, let's say has a little bit of a lifting force here, which isn't enough to get it off the ground, but it is at least something, this reduces the amount of normal force that there is on the object. Because in order for this object to stay on the ground, you need the force of the lift plus the force of the normal has to be equal to the force of gravity. These up forces have to balance these down forces. Otherwise, this thing would fall down to China. We don't want to do that. So if you start adding more lifting force, you don't even have to get it off the ground. Just by virtue of you helping put some force on this to bring it up, you're going to decrease the amount of normal force, which means the friction, which is mu SFN, this is also going to decrease then. It's very cool. I always get confused in physics problems when the equations are just scalars and it's a vector equation. Fg equals mg is true for vectors too. Yes, that is true. That is funny. Yeah, you guys are coming from a heavier math background into like physics land where, yeah, we tend to be a little bit more hand wavy with what are vectors, what are scalars. You are right that this is a vector, this is a vector. Friction, yes, you're right. Well, here's the other weird thing about friction. Friction, the direction it acts can't really be seen in this. Friction always acts in the direction that opposes where it wants to go. It opposes the motion. So, for instance, if you have, this is the classic question they always do. If you have like a block, right, and it's just chilling on this inclined plane, all right, there's going to be a force of gravity pulling it down, right? You're always going to have a normal force here. Remember, normal, 90 degrees. It's always 90 degrees to whatever the surface it's on, okay? And let's say there is friction. If I have no other forces acting on this thing, this block will want to move down. It'll want to fall down the plane. And because of that, friction is going to point in this direction. And that would be equal to, right, yeah, mu KFN is what it would be, okay? Now, let's say instead that you're pushing the block up. So let's say you have a person here who's like pushing on it, okay? And now there's a pushing force in this direction. Well, now friction is going to oppose that motion, so friction will actually point in this direction. But it's the same equation. It's still mu s, or mu k in this case, Fn. So this is why in physics you have to kind of think about where is the thing trying to go, and then friction is opposing that. They do the same thing. If this is the classic question of if you have like the car is moving, and you have, I don't know, like a box on top of a box, and like the car starts accelerating. Sometimes they ask like, oh, what's the force of friction on the box here, right? In this case, the box wants to stay still relative to the truck. It would love to just like chill here, and then the truck just like goes off. And so friction in this case actually points in this direction. Friction is what keeps the box moving at the same acceleration of the car. And this is one that screws up students all the time, because they're like, wait, well, why is acceleration pushing me forward? Or why is friction pushing me forward? And you have to think about like what would it want to do? The box would just want to stay here. It's like when you pull the rug out from the table. What in the goofy car is this? I know. It's a truck. It's a truck bed or something. I don't know. There you go. There you go. You want to see? There you go. Okay, whatever. I'm not the biggest artist. I'm not the best artist.
It's a 4B.
It's a 4B. Dude, what did Marijuana post? Subjective images versus injective images. How to test if these two are the case. Injective means that every input from your domain leads to one output. Isn't that the same criteria for functions? Is this even the right place to ask my question? I mean, it's definitely a tricky one.
It's like my cat, the cat in my profile picture drew it.
This is something that Zach and Ian Stuckey probably know more than me. This is like a, or even Hypatia. Hypatia, have you heard of this? Surjective versus injective images. What is this, dude? What is this?
What did you say?
Are these math terms that I don't know about? Surjective versus injective. What is this?
Surjective images versus injective. Well, there are surjective maps. I don't know what are surjective images. How to test if these two are the case. Also, if I'm correct, injective means that every input from your domain leads to at the most. Yes, that's correct. Isn't that exactly this criterion for functions in general? Yes. So there are things called injective functions.
Okay.
But I don't know what are injective images. Well, they might be saying like functions that can be represented as a subset of the Cartesian products of domain and codomain. But
Codomain.
did you find a page about what a surjective image is? I don't know that.
Yeah, let's look one up, dude. I'm curious. I guess surjective function, I guess.
The surjective function is a thing. It means every element of the codomain has at least something mapped upon it.
Wait, why do they call this the codomain? Isn't this called like the range? Isn't Y usually called the range in this case?
Range is the image of the function.
Okay.
Codomain is something that might be larger than the range, than the image.
Oh, okay. It is not required that X be unique. The function F may map onto one or more elements. Okay, yeah, okay. It's like a fancier way of defining what a function is. Okay, and then this is a non-surjective function. The image does not fill the whole. Okay. I'm seeing, yeah, like it's a set. Oh, okay. I didn't know that, Zach. I didn't know that there was a difference between a range and a codomain. That's actually that's pretty cool. Okay. So yeah, maybe that answers your question, Marijuana, a little bit. Yeah, I guess this is called non-surjective. Okay. Because there are certain values of Y that can't get hit. I guess. The codomain is R, but the range is 0 to infinity. Ah. But is there no such thing as image in mathematics? It might be different in English, though.
Yes, there is this thing called image. Image is a so you have say like a subset in the domain of a function. You can take its image under that function, and then it's going to be mapped towards like the into the codomain.
Is the
Or
image the
it
same as the
can
is the
mean-
image the same as the codomain? It says the image of a function is a set of all output. Oh no, it's not then. Okay.
It's the same as the range. If you just say the image of the function
It's the
instead
same
of
as the range.
image of a subset of the domain under the function, then it's just the entire domain. It's the range, as you said.
Ooh, here we go. This is like group theory. Yeah. This
or
is
yes, you can use category theory to define what an image is.
that's pretty cool. Yeah, I like that, Zach. The f of x is r to r. F of x equals x squared. Yeah, exactly. Yeah. Okay. Yeah. I mean, it's interesting. They teach this to kids, early on in like high school. When like, what's the domain and the range? Right. If this is f of x is equal to x squared, this is only going to hit positive values for the, I guess what you would call the range. But the codomain is all real numbers. Yeah. Jamarcus says I'm out. Jamarcus, no, don't get scared, Jamarcus. This is fun stuff. What's up, Rebold? Yeah, that's cool. I'll be back. Oh, it can be your question now, Jamarcus, if you want. I like that question, marijuana. It's actually kind of cool. I learned something today. I like learning stuff. Learning stuff is dope. Okay, this didn't really answer my question, but at least I know that there's such a thing as, well, yeah, you're welcome. Okay, yeah, good. If you have more questions, marijuana, DM Hypatia. Hypatia's great with this stuff.
Jamarcus is just like, nope, I'm out, and I'm sitting here with my brains coming out my ears.
It's good to learn new stuff. I liked it. I thought it was cool.
I feel like a small child trying to understand complex physics.
Well, yeah. Well, no, the physics was kind of earlier. Wasn't so hard. The math stuff, I think it looks scary, but it's not actually scary. When someone explains it to you in simple terms, when I heard like, oh, it's just like the range and what, I'm like, okay, these are just like bigger. They're more, I guess, rigorous terms that explain like much bigger concepts than you're used to dealing with. But at the end of the day, it's all the same stuff. Like it's not that bad. But here, I'm gonna say DM Hypatia. They are very knowledgeable with high-end math stuff. That's why, yeah. I think the question originally asked is asking about the traditional definition of a function from high school math. Usually says that one input maps one output. I agree, and I think what we said is that's not correct, right? Like in the big math term of the big math world of everything, like completeness. That's what they said, I think, right? Was this? But what was injective, dude? What was injective? Is injective non-surjective?
Injective means like 1-to-1. So
Okay.
there isn't an element in the codomain such that there are more than one element in the domain that maps onto it.
Okay. Right, like f of x is equal to x squared. This is not injective. Not injective. Right.
It's not surjective as well.
It's not surjective either. Okay. Because
if you consider it as a real-to-real function, then it doesn't hit the, let's say,
right, it only does this.
1.
Got you. But like f of x is surjective. It's just equal to x. Sorry, equal to x. If f of x was equal to x, that's surjective.
That's
okay.
Injective and surjective. It's called bijective.
It's bijective. Oh wow, that's cool. I think that's okay. These are all like fancier terms that again I haven't really seen from teaching high school, college level math, but. And then what? Something like
another thing that you might want to consider is called Cantor-Bernstein-Schroeder theorem. That's a big thing in foundations in set theory.
Hypatia,
If you have a
Marijuana's asking if they can DM you. Hypatia, I assume yes.
okay, of course. Go ahead.
Yeah, of course.
Whatever you want to ask.
Yeah, Hypatia's great. We love Hypatia.
That's dope.
All right, where's Jamarcus? Did you need What did you want us to explain that one nightmare of a question that we had, Jamarcus? Is that what you wanted, or do you have another one? Do you have another one that's just gonna hurt me? which one did you want? You have another one. Oh God, dude. 2 options for today, he says. All right, let's see. Let's see how much pain we want. Jamarcus,
Go after Jamarcus.
did you post a screenshot? Where's your question?
It's in a common area.
Oh, don't do that. You know, you've been here long enough. You know where to post the questions.
I know, but I can't. I already posted there, and then I'm gonna have to find it everywhere. I ping you.
We'll
That's
go
the first
find
sentence.
go find it again.
Oh
Because it's either you're gonna find it or I'm gonna waste time on the stream finding it. So you go find it.
no, you're not. It's in common area. I pinged you. It's right in the
Oh,
bottom.
Okay, all right. I'll go get it. Oh, I forgot. Jamarcus's images are always like super high res. God damn it, I forgot. God
Yo.
damn it.
Bro has a telescope instead of a computer.
I don't know how. I still. Yeah, there we go. Yeah. This is like, look. I can like. I get really.
Yeah.
Jesus Christ. Okay. Is. Here. Can I rotate, please? Thank you. Wait, why is there a rubber ducky in this picture?
Don't even have a duck, bro.
What's with the duck here, dude? What? Excuse me? What do you mean I don't know?
Bro put a duck in his
He
leg.
says I liked the duck. Okay. Okay. A roll of tape is 4 inches in diameter, is wrapped around a ring that is 2 inches in diameter. A cross-section of the tape is shown. If the tape is 0.15 inches thick, if the tape is completely unrolled, approximately how long would it be? Oh, this isn't too bad. Isn't this just like calculating arc length, but like the radius just keeps increasing, right? Yeah. Round your answer to the nearest 100 inches. Oh, I feel like this is a simple question. I hope, but it's from the math
I'm trying
comp.
to figure out what's weirder.
Yeah, the duck, the duck, or this, right?
The
Yeah.
duck, the sunglasses, or the bikini.
Wait, the duck has a bikini on, dude. What?
You didn't see that?
Y'all are looking for the duck tits, dude. Y'all need to chill. Okay.
Bro, Jamarcus needs to chill. Why does he have that
I
around, bro? It's
know.
crazy.
Okay. Okay, so here's what's gonna happen, Jamarcus, is we're basically, and again, I'm sure there's a more exact way to do this using like integration and stuff, but we're basically just gonna add up a bunch of these little circles, right? Okay, whatever. So first, I want to figure out how many layers of this that I can have, right? How many layers? So we're going from 4 inches to 2 inches. So that's 2 inches in thickness of tape. And we say that the tape is 0.015 inches. So I can divide that by 0.015. And that'll tell me how many layers I get. And then each layer, here's where we may need to integrate, actually. Yeah, I take this back. We may need to integrate this. Where's my calculator? Where's my calculator go? There it is. One second. I need to. Because wait, are you allowed to use calculus on your classes? Like, are you assumed to know calculus, or do we have to do this algebraically? Because I think you can do this. You can do this both ways, but. Okay. All right. Okay. So we do 2 divided by 0.015. Okay. So that's 133 layers. Okay. And then, I think the quick and dirty way is to calculate what the circumference would be here, what the circumference would be here, and then just take the average of it. As like, what's the average circumference that we're going to do with each one of these layers? Yeah, you only have to estimate it? Okay, cool. Then yeah, that makes sense. So the average circumference is going to happen when we're 3 inches out, right? So that's pi times 6 inches. So 6 pi inches. That's the average circumference. Does that make sense, Jamarcus, between the 2-inch and the 4-inch spot? Oh, wait, no, sorry. I'm reading this wrong. It's 3 pi. Yeah, it's 3. Wait. This is 1 inch. This is 2 inches. It's 1.5. So it's 3 pi inches average diameter. Okay. 3 pi is approximately 10. So 10 times 133. So I'd say, yeah, it's around 1300-ish. So I think this is the closest I would say. I think I'd say it's C. It's around like 9 or 10. Do you have the answers for this? Is this correct? Yes, Cruz Boj, I can. Are you in our Discord? It's a lot easier for me to help you with questions if you're in our Discord. Just join that. Or you can you could type it, I guess. Oh, you don't have the answer key, so you don't know? I think it's this. I mean, they probably have this on Chegg somewhere. Someone's like, "Wow, Chegg is so expensive." I'm like, it's basically a business expense at this point. Because they charge like $15 a month now, but I use it so much to verify myself. Yes, yeah, I could try the other one if you want.
I got a question for you.
What's up, Sensation? What's up?
Can you write the symbol for direct proportionality? Because I can't.
Sure, yeah, I can do that for you. That's an easy one, I think.
Totally don't get it. And end up looking like alpha. That's how I finished.
Well, yeah. Okay, so if something's directly proportional, right? We say y is equal to like alpha x. That's what we say. Where this is what's called like the constant of proportionality.
Constant. That's slightly different for us. It's kx, but
all right, sure. Yeah, we can call it kx. Kx is cool too. That's fine.
The point is the symbol is Duomadin. It looks like a half infinity symbol.
It looks like an infinity symbol.
Or half an infinity symbol.
So it's like this.
How you'd draw
Oh, you don't like alpha because it looks like half of an infinity?
No, because alpha looks like alpha, but this weird half infinity symbol looks like a weird half infinity symbol, and I'm just.
Oh, show me a picture
really
of it. Show me a picture of it. That doesn't make any sense. What? I've never seen this.
Hang on.
All right. One sec. And then while he's getting that, I can do this one real quick for Cruz. This is easy. Sine of 3x over, what is this? Square root of x plus 2 minus the square root of 2? Is that what this is? Okay. Do you know calculus? Are you allowed to use L'Hopital's move, Cruz Boj? Because what happens is, if you plug in x is equal to 0 into this, right? I get square root of 2 minus the square root of 2. So that's equal to 0. Sine of 0 is 0. 0 over 0 means we get to use L'Hopital's rule. So just take the derivative of the top. So that's 3 cosine of 3x all over, this is 1/2 x plus 2 to the minus 1/2. That's how I do this derivative real quick. So x plus 2 to the 1/2, right? Just becomes this. Oh, yeah. It's like an alpha. It's like an alpha, but it's not.
Hang on, I can't
No, I know what he's talking about. You're talking about this. You're saying this is it like this? This weird thing? Oh, here, let me pull you up 1 sec. Uh-huh. Yeah. No, I know what you're talking about. Yeah, you're talking. Yeah. One sec. Cruz, yeah, you have to take the derivative of the top and the derivative of the bottom. This is a constant, though, so this goes away, right? This is 0. This is this. And then now we're left with the limit as x approaches 0 of this. Let's see if that makes something nice. Cosine of 0 is 1. So this is just going to become 3 on the top. And then this becomes 1/2 1 over the square root of 2, right? So what is that? 6 square root of 2? 6 square root of 2? I think it's 6 square root of 2. You can always check this. So if we do... Cool thing is, like, I can literally take your text here. Watch this. If you don't know about Wolfram Alpha yet, Wolfram's the GOAT, dude. But yeah, 6 square root of 2. So yeah. That's the correct answer. Yeah, nice. Good job there, Cruz. That's a good question. Real fast one. And then, yeah, sensation. Yeah, so that thing you saw is it's just kind of like a weird equal sign is all it is. But it's not free. No, Wolfram Alpha is free. If you want the steps, it's not free. Yeah, if you click this and you want the step-by-step solution, yeah, then they start charging you money. But actually, there's a hack to this if you want to know. So if you get the mobile app so they'll charge you here, I think, per month. I think, what do they want? Yeah, they want like $5 per month. Like, no. If you get the Wolfram Alpha app on the phone, you pay a one-time price for that, one-time fee for the app. And I think it's like $5. And then you can see the solutions on your phone. So everything that happens here you can do on your phone, and you don't have to pay monthly. I think that's the workaround I saw. The other one that everyone they also like Symbolab. I think Symbolab does this as well. I think Symbolab is free. Like if we put this in. Oh, but it doesn't know how to do this. Yeah, see, yeah. I'd have to actually type it in and whatnot, but Wolfram Alpha has a much better language processor. They're able to process what the text you put in and turn it into math. But yeah, I think, one sec.
What about Photomath?
Photomath? Yeah, Photomath is probably, I don't know. I'm old school, dude. Wolfram Alpha was always my, let me say, like, app, iPhone. I think it costs money. Let's see. Well, where is it? Can I just... I know I bought the app. Here you go. There you go. It's $3. I'm pretty sure if you pay the $3, you then get access to all the solutions. Without having to pay monthly. I'm pretty sure. Oh, well, this says Pro for students monthly. Maybe not. I know on Android you don't.
So you have to buy the app and then buy the monthly.
Maybe. I can't confirm. So anyone who has an iPhone probably... I know for Android, I bought this app once, and I spent $3 on it, and I was able to... Oh, wait. Oh, they've changed it. Until it was just like almost every other... Okay. Yeah, because originally it didn't. Oh, maybe I'm grandfathered in then. Do I have like a grandfathered version of this app? Yeah, dude, I hate all these...
Two different ones. I just looked on my phone. Classic is $3, and the regular is $0.
Yes. So get Classic. I think Classic, the one that you pay for, I think includes the free solutions. Whereas the other one, they want you to pay $9 a month, dude? No. What? Bro, that's like another like Netflix subscription or something. Dude, what's with all these subscriptions?
Let me download it right now.
Like, stop. Yeah, you try it. Try it and see if it works.
You didn't know the obvious as well. It was more expensive on mobile.
Yeah. What was more expensive on mobile? Sorry, what'd you say?
Wolfram Alpha is more expensive on mobile.
Yeah. It's like, yeah. Well, it's well, no, because I think it's...
Twice the price.
Oh, I saw that. Yeah, because it was $10 per month. Yeah. Yeah, that's weird. I don't get that. I think the other thing was a discount if you paid for a year up front. You know how this works, right? They want you to pay for all 12 months, and then they'll cut you in on a deal, but now you're committed. Yeah. But anyways, what you were seeing, just real quick, and then Teacup, I'll do your question. You were seeing like this, right? It was something like this, and then it was KX, something like this.
Yeah, and then when I was trying to write it was just looking like Alpha.
You can write Alpha, honestly, if you want. No one's really going to mark you down. This is just like a fancy equal sign. Like, it's sometimes they say, I will mistakenly say this sometimes. I'll say, yeah, F is kind of like KX. But really, this is supposed to be used for approximate, is what they're supposed to say. This is like, it's approximately something. And then, right, this is the more rigorous form of F is equal to Kx. Yeah. I think usually they don't say Kx. I think usually they just say they say F is proportional to X. And then you have to figure out what the constant of proportionality is, which just means, you know, if this, for instance, doubles, what happens to this, right? If this goes up by a factor, let's say that when this triples, this goes up by a factor of 6. What was the K then?
If that triples.
Yeah.
then that goes-
If X triples, but
Oh,
this
I see what
goes
you
up by a
mean.
factor of 6, what was
So
K?
then K is equal to F over X.
F over X, right? Yeah. So you could say the 6 over the 3
It's
is what?
3.
What's 6 divided by 3? You got it.
2 even.
2. Yeah. So in this case, sensation K is equal to 2. If I had like, right, F is equal to 2X, you can kind of test this, right? Let's you know, let's say for instance I just had 3 to start with, okay? I would have, right, then F would be equal to 6. Then let me try tripling it. So let me make this now equal to 9. Then this becomes 18. Right? Wait, one sec. Oh, actually, no. This doesn't change it at all. What am I talking about? Wait, factor this triples. What did I do wrong here? No. No. Okay, one sec. I just had a brain fart moment myself.
Don't worry about it. I'm not struggling with this too much. It's just the minutiae that's
Yeah, it's
irritating
it's
me.
whatever. Yeah. Actually, I think what they say is if it goes up by a number is what it is. That's what it is. Sorry. Yeah. Sorry. It's not if it doubles or triples. It's if it's an addition thing if it goes up. That's where it is.
Well, so far it's been having me fill in tables.
Yeah. Well, you're gonna do like whatever, like f of x and then x, right? And then
Well, no, it's just that X and Y is the
well, this is the same. This is the
horizontal
same.
parameters.
This is the same thing as y. F of x is the same thing as y. In your textbook is what it is. Oh yeah, you know what I fucked up on? Sorry, no. If this doubles and this like goes up by like a factor of 9, then this is x squared. That's what I meant to say. Sorry, I screwed up on that. Yeah. The concept of proportionality, that just talks about what happens, I think, if you add things, for instance, right? So if this goes up by 1, this goes up by 2, right? You see it goes up by 1. This goes up by 2. So if f were equal to 2x, okay, then your constant of proportionality is equal to 2.
Sort of merging all of these concepts together.
Yeah, so this is directly proportional, okay? Then you can have what's called like inversely proportional, which is another one that people like to see a lot. So I could have, for instance, f is equal to 1 over x. And what this means is that as this goes up, this goes down. Okay? So again, if we have like f of x and we have x, right? Let's say x is equal to 1, 2, 3. Then this becomes 1, 1/2, 1/3. Okay? This is called an inversely proportional.
That's the next page.
Okay, good. And then the other one you can have is you could say that it goes by the square of it. So I could say f is equal to the square root of x. This is square root proportional.
Yeah, other types of inverse proportion.
Or I could have f as x squared, and this is proportional by the square is what they say. So this is proportional by the square root, proportional by the square. This happens a lot in physics. Certain things are proportional by either being squared or being square rooted. The classic one is like kinetic energy is 1/2 mv squared. So we say that kinetic energy is proportional to the square of the velocity. And that's the original thing was what I was saying, is that like if the velocity, for instance, triples, if this goes up by a factor of 3, this goes up by a factor of 9. And you'll get to this. But this is all just like tables. Like look here in the tables here. Look, this is f, and this is x. So if this is 1, this is 1, right? If this is 2, this is 4. If this is 3, this is 9, right? So do you see how, right? Going from 1 to 3, that was a multiplier of 3. But f went up by a multiplier of 9. That's what happens when something is proportional by the square. Yeah. That's what I meant to say when I was doing this 2 and 6 thing. I had that wrong. Yeah. Okay. Cool. That's a good question though. I like that one. Here, let me do teacups, and then if I have time, I'll go do some more Jamarcus questions. Those are always fun. Yeah, you got this, Sensation, dude. I believe. When's your GSCs? They're in what? In March?
Sorry, I'm using me to hear you say that.
Yeah. What's up, Hypatia?
You want to answer that one? The solution I typed?
And I want to do the one you typed. Yes, I do. Yes,
Oh.
I do want to do. I will do that.
Tell me if you want some clarification or anything.
Yes. Let me see. Who's the next screenshot I had? Teacup. This is the study guide. You can choose approved problems you might feel like are a good review. Okay. Yeah, we got a lot here. Ooh, I like these. These are all the similar polygons. These are fun.
Anyway, in answer to your question, the first exam is on May the 16th, and the second exam is on June the 3rd.
Okay. So yeah, you got what, 3-4 months then, right? Yeah.
Hmm.
Vector bases are cool. What's up, Unaccessible?
No, exams. I hate them. Let me tell you guys a bit about exams. So,
What do you want to tell us about exams? Why wait for this to load?
First exam, I did so great.
Okay.
This exam, I failed. Well, I was.
What was the difference? Why did you fail the second one? Oh God, you guys with these pictures, look how high res these are, dude. They're nuts.
Like, because I didn't understand the material, I kind of forgot to come to you and ask. What it
Oh,
is.
okay. Well then, yeah. Please come by, ask questions.
Yeah.
Teacup, come up to the stage, Senor Teacup. Yes, Nick. I'll do yours next. I'll do yours after Teacup. Yours would be next, Nick, but you didn't post it in the right place. This is what happens because I have a lot going on. I can't remember everything, but I know the questions. If the questions are in that channel, that's what I go through. Where's Teacup? Teacup. Mr. Bean gonna wait? We chill around. Mr. Bean's gonna start waiting here, dude. There he is. There he is.
Mr. Teacup, what's up?
Senor Teacup.
Senor Teacup.
I could kind of hear Teacup for a second there.
Hello.
Hello. Jamarcus says, good news, I maxed out the score on my standardized math test. Good job. Yeah, you should be getting perfects on that. Absolutely perfects. Yeah. Okay. Let's try to do this one, Teacup. This is a cool one. I actually like this one. Do you know how to do this one? I almost don't know how to do this one.
We got 2 triangles. We got a angle bisector in the middle.
Uh-huh. This is an angle bisector. Good. Splits it.
And now we're trying to find what x is equal to.
Mm-hmm.
My math ain't mathing.
Okay.
What page is this on?
This is the first
The
page you
last
sent me. No, this is the first page you sent me. It's number 15.
Oh, it's the last page on my document.
Oh, okay.
Let's see. So we got angle bisector 16.8x. We don't know what the middle angle is. The middle line.
The middle line. Yeah, we don't know what this is. You don't need to know what that is actually though. So this is interesting. Well, we have inscribed triangles is what we have here, right?
Mm.
Yeah?
Yeah.
I mean, you could also use
I
use
don't
law of
think I've
science.
learned with people.
It's not hard. Okay, so first of all, you know what this triangle is, right? Because if this
Like
is 12
that
minus x,
triangle?
and this is x, this is just 12, right? This whole side here is just 12.
Yes.
That kind of helps you out a little bit. Okay.
16, 12.
Mm-hmm. So here we go. This is the first triangle you have. Okay. This is 12.
Yep.
This is 16. This is 8. Okay. And this has this angle. Well, actually, it's double of those, isn't it?
Yeah, it would be the entire.
Oh, maybe I don't want. Maybe I don't want that one then. I don't want that one actually. I don't think I want that one.
Man, math ain't mathing.
No, it's a
I
good
got
question.
my quarterly assessment tomorrow.
It's a good
I'm gonna
question.
fail.
It's a good one.
I got my
Okay.
end of semester assessment.
Here, okay. This is what I actually. Here's what I want. I'm pretty sure I want this triangle,
Yeah, I want that triangle.
and then I want this one. I don't want the whole one. Because what you need is these triangles to have like angles and
The shared
sides.
angle. Shared side, shared angle.
Right. Yeah. So these two triangles share this side.
Yes.
I forget who was streaming. I think it was Danny Highway. Danny High was like I abhor like geometry. I'm just like I kind of do too.
I even hate geometry.
It's funny. I actually have to teach a student in that after this. I got to teach a student geometry, but it's Pythagorean theorem, which is like whatever. Okay. So
Not geometry.
these angles are the same, right? So I know that this is equal to this,
Yes.
and that this side, right, is equal to this
It's
side,
congruent. It's
right?
congruent on both sides.
Yeah. So this is equal to this. Cool.
Yes.
I
I don't think that helps us.
Well, kind of does. Because I know that this is 8 then, right?
Yeah, you know that's 8 because it says it's 8.
Uh-huh. This is x, and this is 12 minus x. Right? And then this one is 16, right?
Yes.
Okay, so I think I see how we can do this. Okay. So this side, right, must correspond to this side, right? See how these are corresponding sides? Because they're both opposite the same angle. Does that make sense, Teacup?
Hold on, am I doing 16 over 8 is equal to 12x minus x over
No,
x?
no. Well, one sec, maybe. One
It
sec.
would be 12 minus x over 16, and then
No. So here's the thing. No, you have to have them have they have to be the corresponding angles. Okay. So this one, right, is then corresponds to this one, and then this one. I need a different color. I'm running out of colors. We'll use peach. This one corresponds to this one. Okay. So, we could do, let me think. So see how this corresponds to this. This corresponds to this, but I don't know what this one is. Right? Interesting. Hello, hey, what's up, Penn Center? We're doing geometry. Your absolute favorite, dude. Wow, thanks, Penn Center. Got another sub.
I heard a ding ding ding. Are you guys done?
No. We just got a sub. I'm just trying to figure this one out. This one is
are you
tough. I want to
That's just
do
a
law of
variety.
signs. I want to do law of signs. I really do. But are you allowed to do law of signs on this? Or should
I mean, if I know what it is,
Or should I just? I should be able to just use similar polygons for this, honestly. Ugh.
you can do law of sign.
What is this? 12 minus x over x. So let's do this. So this one and this one, we're going to correspond to each other. So now I need to correspond something here to something
Isn't
here.
it? No, hold on. Wouldn't it just be 12 minus x times 8 and x times 16? That gets you x equals 4.
For what? Sorry, what?
If you do 12 minus x
Uh-huh.
times that by 8, and then
Wha-
do
Why am I multiplying that by 8?
x, well, because you put it over 12 minus x over x, and then you do
Is equal
what
to...
was the other one? Is equal to 16 over 8. And
It's
then
not 16 over 8, though. No. Because 16
Eh.
is opposite this angle. And this is my, like... This is, like... This is 16 opposite mystery. Is what it is. Right? But, okay, here's what you can also say, though. I can say that 12 minus x over x is also equal to 8 over is equal to mystery over 8, right? Do you see that? Because this one over 8 and then 16 over this one. So actually you can solve for this pretty quickly. Let's call this thing y. Okay. 16 over y is equal to y over 8. Do you see that, Teacup?
Okay, well, now you got y squared.
Okay. Y squared is equal to 128.
Now you got to square root it.
Oh, that's not nice, is it? Man. Okay, so then we get this, right?
I don't think it's meant to be this hard.
I don't think it's meant to be this hard either. What's up,
don't think
Abot?
it's-
I don't know. I mean, it may be a square root, honestly. It may be. Right? Square root of 128 is nothing nice there. 16, 8, 12 minus x, yeah. Aimbot? Maybe. I have a lot of people in the server. Okay, I just don't like that. That answer is just super ugly, dude. What? So that's 8 plus the square root of 128 times x is equal to 96, right? So x is equal to 96 over 8 plus the square root of 128. Ew. I don't like that. What do we know? That just the two angles are the same? Yeah. Yeah, we just know these two are the same. Pensender. I feel like I should know this one, but again, this is the whole thing Danny yells about with geometry, is that there's some weird rule that I don't know.
I'm pretty sure it's just similar it's similar figures.
Yeah.
So you have to set up a proportion.
That's what I did. I did set up a proportion.
And the proportion is 12 minus x over x equals 16 over 8.
I don't think so because those are opposite.
Try it.
No, it's just not though, because
Do it.
teacup. 12 minus x and x. I agree. You can put those because those are opposite this angle, right? Which is the same. However, you can't do 16 over 8 because 16 is opposite the big angle, and 8 is opposite the small angle. Those are not corresponding sides. Hey, thank you, Dawn. 12 minus x over x is 16 over 8. Oh, really? By the angle bisector theorem? Okay.
I told you.
See, but this is what I'm talking about, Dawn. This is what Danny High was talking about. Like what? How I don't remember the angle bisector theorem.
Buddy, I told you 20 times, and you're like, nah.
Nah.
X is equal to 4. There's your answer.
12. What is it? 12 minus
X
x
equals
over
4.
x is equal to 16 over 8. Is that true?
Yes, it is. It's X equals 4. You look at all the other problems next to it, and you figure out the exact same theorem.
But like, why did my version not work?
Because your version sucks. You're over here trying to overcomplicate it using. I want you to look at number 13 on the other side of that paper real quick.
Well, I'm just wondering why this doesn't get me the right answer.
Well,
What's- what-
I don't know.
Well, because I thought if I broke this up into two triangles, right?
Yeah,
And
that's what you
then
meant to do.
these have the same angle, right? This is the shared side, which is this side. I called this Y on this one, and I called it Y on this one. And then this is X, and
We
this is
just
12 minus
did it. I
X.
think we broke gold. We broke gold.
Oh, they're not necessarily similar. Ooh, thank you. No, that's all I needed to hear. Well, I get you. No. Now I agree with what Don's saying. Yeah, Don, you're right. He's saying that this angle does not equal this angle. You're right. Cool. All right. Nice. Good. I like that. What's up? You wanted me to see one other thing, Teacup? What's up?
Yeah. Can you go to the what was it called? The Chapter 5 midterm review page.
Chapter 5 midterm review page. Chapter 4. Yeah. Which one?
The one on the bottom left. The bottom 9.
Where it says
I
median
would
and
never taught
altitude.
those. I would
Median and
never taught
altitude.
those.
Okay.
I was absent today of that teaching.
They're just asking like which one's which. That's all they want. They just want to know what's what. No, this goes away. Sorry.
Yes.
Okay. Well, okay.
I'm
You know what an
wasting
angle.
my life to make
You know what an
math.
angle bisector is. We just did an angle bisector. Which one's the angle bisector?
Yeah. Probably like C.
Oh, good. All right. This one's C. Well. Good. Right, because it
Perpendicular
bisects angle in
bisector
heaven.
is D.
Which one?
Perpendicular is D. Median is probably B, and altitude is A.
1 sec. No, perpendicular bisector is A. Okay.
I don't know this stuff.
Well, bisect means that the segment is split into two equal parts, right? This is
It is not
bisected.
on the- Okay,
This is
then D
bisected, and then this is perpendicular.
It is. Then median is D.
Median is D. Are these the same? Yeah. Yeah. So if these are the same, right here, and these angles are
Yeah.
different, yeah, then this is a median, and then good, this is an altitude. Yeah. Altitude connects a side to its opposite angle with a 90-degree thing on it. That's an altitude. A median connects a side to a vertex but splits it in half. And then a perpendicular bisector doesn't necessarily connect to a vertex, but it does split the segment in half.
Man, I got way too much math to do. I have no idea how to do it.
Do you know how to do this? This is all just memorizing shit. This is honestly why I don't like geometry.
It's a 25 question multiple choice one. It's
Don, do
not
you like
gonna be
geometry? Don, are you a geometry enjoyer? Like, I just don't like it. I feel like it's the puzzles of math. It's
Gold, have you ever heard of a Scantron?
yeah, hate it, dude. Thank you. I'm glad.
That's what
Everyone says I
that's
hate
what
math. We hate geometry. We don't like geometry. Is like the ugly duckling of math. It's just weird. It's just all these shapes and these weird properties. And
Can we go? I want like physical math where you actually do the math and you.
well, that's physics. That's physics. Physics is physical math. That's what I say.
Yeah, give me physics. I want physics. Physics is good.
The median of a triangle is a line segment that joins one vertex to the midpoint of the opposite side of the triangle. What's up, Falcon? Good to see you. Yeah, right. And that's what join one vertex to the midpoint. That's what this is. That's what we said the median was. Yeah.
Alright, good. I'm gonna give you 3 options, and you're gonna choose which one I should do. Should I A, finish my math midterm review? B,
I'm going with yes on that
study
one.
for French?
No.
Or C, study history?
I think you need to study math. French is easy.
See,
You already
but-
speak French, dude. What are you talking about?
Yeah, we don't talk about the French one. It was an obligated option.
Yeah. Tarvik has asked a bunch of questions. That's cool, but here, let me do Nick's first. Oh,
Yeah,
the Half-Life one. I like these. These are good. 1 second. Let me grab these.
Okay.
Yeah, go
what
study
do you
math.
think?
Tell me if you get confused with it.
I'm gonna get a 0 on this assessment. I'm gonna come back to you and I'm gonna yell at you.
No.
I'm taking away my subscription.
Okay, here we go. All right, I got a D in nuclear chem homework. Uh-oh. It's because I got 3 questions wrong. Can you help me with them? Okay. This is cool. Half-Lives are fun. Oh, Jamarcus, you gotta leave? Okay. Peace, Jamarcus. Okay.
Yo,
What's up, dude? Need some help with this?
I'm playing chess while listening to you, so yeah.
Oh, well then stop playing chess. Bro, I'm trying to teach you. Don't multitask.
I'm listening.
No, you're not, no. Put down the chess. Put down the chess. Yeah. I always say, je suis un pizza. I'm a pizza. Je suis un beau cochon. Beau cochon. I'm a beautiful pig.
Oh.
That's what I always say. Okay. One isotope of BR has a half-life of 16.5 hours. How much of a 2-gram sample remains at the end of one day? Okay. What do you know the equation for half-life and exponential decay? What's the equation? Okay.
I don't remember the
Okay.
equation.
Well, remember it. Come remember it real quick and tell me what it is.
Gordon Freeman.
Wake up, Mr. Freeman. Wake up and smell the ashes. That's a classic one. And what's the other one? From BioShock, where it's like a man something, a slave obeys. A man chooses, a slave obeys. Would you kindly? That was the biggest like mind fuck of video games, dude. BioShock was a great game. Absolutely great. Pineapple on pizza, I do. Yeah, pineapple on pizza is dope. Okay, Nick, did you find your Half-Life equation? Because there's a bunch of them.
Yeah.
I want to know which one you use.
I'm sending him right now.
This is it? Does it look like this?
A little bit, yeah.
Some of them use like the LN version one. Formula, you like this? Okay. Okay. Whatever. So, how much of a 2-gram sample? So that's what this is, Nick. NFT, this is how much remains. This is what we're looking for. It's like question mark is equal to. N0 is what?
Initial quality.
Initial quality, good. Which, do you see how that's 2 grams, right?
Yeah.
Good. And then
If
we're
you
going to
want,
multiply.
I can send you the picture of. I tried to do the question.
Well, here,
I
no.
might have done it wrong, but like.
Well, here, we'll just see if we get the same answer. 2, 1/2,
Yeah.
and then T here is the time, right?
Mm-hmm.
So, what'd you put for the time?
I put.
I already know where you.
What the hell did I put?
I know where you're gonna go wrong.
I don't know why, but I put 2H or 24.
Yeah.
24.
24, because they want 1 day, but your half-life is given in hours. So this
Yeah.
that's why you need to put this time also in hours. So that's 24 over a half-life of 16.5. Okay. All right. So that's all you have to do. So then, pull out the math, pull out the calculator, right? So 2 times 0.5. You may fuck this up, like putting it into the calculator. You have to like kind of
Maybe, I don't know.
You got to put parentheses over this. This is like this will get
But if
screwed
it
up.
comes out as 0.73, I don't know. The teacher it's smoking something.
Yeah, it's 0.73. Yeah. Yeah, should be 0.73.
So how exactly is that wrong?
Oh, it's not wrong. Should be point.
So
I don't know
so my teacher is smoking.
how many sig figs they want. They want 3 sig figs. So 0.7. Did you do this? You need 0.730 technically.
No way. I put 0.73 only.
Oh, maybe put 0.730, because there's
Bruh.
there's 3 sig figs here. There's 3 sig figs here. There's 3 sig figs here. Again, I don't know. It depends how picky your thing is.
Yeah, I mean, I don't know.
Okay. All right. Whatever. I think that's the right answer. Well, I know it's the right answer. How do we do this one?
Same thing I did, but I used the different formula, the T halftime
Okay. With the lns and
formula.
everything.
Yeah, with the log.
Yeah. Okay. Cool. Yeah. Yes. Let me just show you how to do it without having to memorize that, because it's a lot easier if you just. If you only have to memorize one equation, then you're fine. And this will teach some good things about log rules. Okay. So I know that 160 grams. If 160 grams of decay, what? Dude, is this even English, dude? I'm having a stroke, dude. What? If 160 grams of a 200 gram of decays, so 160 grams decays. So that means you have 40 left. I think that's what they're saying here. Okay. If they're saying 160 grams decays out of 200, I assume that means we have 40. And we started with 200. And then it's 1/2. And then the time, we say that is 6.25 days. And then we're solving for T1/2. Okay? Yeah, where you got this wrong, I bet you used 160 as the number here instead of 40. I think that's probably that's probably where the problem came in. But again, it's worded weirdly.
Picture after.
It's worded really weirdly. Okay.
Yeah.
Divide by 200. That's 1/5 is equal to 1/2 6.25 over T1/2, right? And then what you have to do is you have to take the log of both sides, because anytime you have a variable that you're trying to pick out that's in an exponent, you need to use logarithms to pull it down. So this is going to be the log of 1/5 is equal to the log of 1/2. And then remember, it was 1/2 to the 6.25 over T1/2, right? But log of A to the B is the same thing as B log A. So what happens is this whole thing comes down over here. So let's take this. Cool. Move this over. Okay. Okay. So now, you do a little bit of algebra, right? So I can move this over. I can move this over. And I get T1/2 is equal to 6.25 log of 1/2 all over log of 1/5, which does look very similar. Here, can I pull this in? Nope. But this is like mathematically where the equation comes from. This looks like the equation your teacher gave you, which was this. You see how you have log of 1/2, you have the time, right? And then AE is the amount of substance left, right? Yeah. Which was 40 over 200, which ends up being 1/5. That's where that comes from.
Oh, maybe that's why I got this wrong.
I think you put 160 here. And again, it's worded weird. Yeah, this is terrible English. First of all, it should be if 100 grams, they should have said decays, not decay. Yeah, okay. So then, yeah, this is just math. Calculator math.
Okay, so the first one was correct, but she said it's wrong.
Yeah.
It's interesting. So if if I get this wrong again, I'm messaging her, bro. A freaking bro.
Yeah.
Person
Okay, so
with a PhD in plasma physics, yo. Said it's correct, bro. What do you want from me?
Yeah.
Yo.
Okay, this should be 2.69 days.
I got 19.41.
Yeah, that's wrong. Okay. So check that one. See if that one's right. Okay. And then this, the half-life of 20 minutes, that just means, right, that carbon loses half of its amount every 20 minutes. That's all it is.
I wrote The half-life of radioactive isotope is the time required for half of the atoms in the sample to decay.
Good. She marked that as
And
wrong.
she said that's wrong.
Okay, whatever.
So what the hell am I supposed to write then?
I don't know. Tell your teacher to read. I don't know. What? I can say after 20 minutes, half of the carbon-11 will be left. You know, and after
Can
40
you write that down so I don't forget?
Well, yeah, sure. Okay, so yeah. Say after 20 minutes, 1/2 the original amount of what is this? C11 remains. Right? And then you can say, you know, after 40 minutes, you know, a quarter remains. And so on and so forth. It just keeps knocking itself down by a half. That's all it is.
Yeah. I in the beginning when I was reading all that, I thought, like, for example, you have 100. In 20 minutes, you're gonna have like 50, and in another 20 minutes, the 50 disappears.
Yeah. No, it's not that much. Yeah.
Damn.
All right. Nice. Good job.
Thank you.
This is going to dark. Your name is Okay. The quantum nature of carbon molecules? No, Penn Center, dude. It's not that difficult. There's no way the teacher's doing that, dog. What? Trolls. Okay. Let me see. I had a couple questions. Falcon, I got yours, which is great. I believe this will be on the biometrics test. Okay. And then let me see. Is Tarkiv still here? Tarkiv, you asked a question earlier that I was going to do. Where did he put it, though? Let me just do this real quick. Take like 2 seconds. It's an easy probability question. And then I'll do Falcons. And then I'll go through the nice proof Hypatia showed us for last week's question. Okay. All right. Let's do this. Yeah. Yeah, good. Summation notation. Yeah, I saw yours. Yeah, that's good. All right. Bag contains 10 cubes, 3 red, 3 blue, 4 yellow. You take out a cube without looking and do not return it to the bag. You did this 3 times. What is the probability that you pick up a red and then a yellow? Uh-huh. That's always cool. The way to think about this, right? Let's say this is our bag, right? And we have, what is it? 3 red. All right, well, let's do circles. 1, 2, 3. 3 blue. 1, 2, 3. And then 4 yellow. Oh, the yellow's gonna be gross to look at. 1, 2, 3, 4. Yeah, I can't even see that. Sorry, I need to use a different color. I'm gonna use orange. 1, 2, 3. Right, no, that one's too big. Okay, cool. What's the probability you pick up a red? Okay, so let's say like the first pick, right? Probability is always just equal to, right, the number of ways you can get a success divided by the number of total outcomes, really. So in the first pick, if you want to get a red cube, there are only 3 ways you can do this, right? I could pick this one, I could pick this one, or I could pick this one, okay? So that's 3. And then divided by, what are the total number of things I could have picked? Well, there are 10, because there are 10 cubes in it. So this is just going to be 3 over 10. Okay. So here, we'll call this the beginning, right? Okay. So this is before, and then this is after, okay? Now, this is an important thing because this is without replacement, which means this red one is now, this red one that I picked in the first pick is now gone. So now when I go for my second pick and I'm trying to get another red, all right, now there are only 2 ways that I can get a red. And even more so, the total number of marbles in here are now not 10, it's 9, right? There's 9 ones I can get that I could get. Red, okay, and then a yellow. So here. So now we've taken this out. Okay. Now for the third pick, there are 4 yellow ones that I could have gotten. And there are a total of 8. What is it? 8 cubes in the bag. So then we're left with this. Cool. Well, no. Nice. Okay. Last step here, Tarvik. Just multiply them all together. Okay. So this ends up being 3 times 2, which is 6, times 4, which is 24. Then 10 times 9 times 8, which is 270. Wait, did I do that right? No, 720. Yeah, 9 times 8. Okay, cool. And then what is that going to be equal to? Probably a pretty low percentage, honestly. What is that? 24 divided by 720. Oh, 0.03 repeating. So 3.33% chance. That's cool. 3 repeating equals 3.3 repeating percent. Nice. Good. Nice. Good job, Tarvik. All right, let's grab that. Doing a lot of questions today. There you go, Tarvik. Oh, send you the pic of what we did? Yeah, I'll send you that as well. There you go. This is Nick. There's that. Okay, cool. Yeah, you're very welcome, dude. Okay, Falcon's question. Let's do it. Okay, let's see. Oh, summation notation. Ooh, I like summation notation. Summation notation is cool because it reminds me of, it's a lot of like programming type stuff. Okay. All right. If x1 equals 4, x2 equals 6, and x3 equals 7, find the following. Okay. So this is like noticing a pattern, I guess. Right? So 4, then 6, then 7. I see this is going up by 2, right? This is going up by 1. Huh. Oh, okay. Okay, no, sorry. We don't need to do that, sorry. Yeah, okay, just look at this. Let's, first of all, there's no limit on this. I think this one should be, right, from I equals 1 to 3, I believe, Falcon. I think that's what this should be. I mean, otherwise, because I don't know what the other ones are. I don't know what x4 is equal to, right? So I assume, is this what we call like the domain or codomain, right? We'd stop at 3. So this is just saying just add them all up. So this is just x1 plus x2 plus x3, which is going to be 4 plus 6 plus 7, which is just equal to 17, I believe. Yeah, I think that's what that is. Okay, taking notes, good. Yes, good. Now. Oh God, no, why do we rotate you so much? There you go. Oh, no. Go straight, please. Okay, whatever, I'll just put this on a new page. No. Okay, whatever. All right, this is saying start at the first one, go up to the third one, but then do this. So this is 2 2x1 squared plus 2x2 squared plus 2x3 squared, okay? So, anytime you have interval notation, if it's just this xi from I equals 1 to like 3, this is x1, and then you go to the next one, x2 plus x3. Now they're doing some weird operations where they're saying, okay, I want you to square each element, and then I want you to multiply it by 2. So this becomes 2 times 16 plus 2 times 36 plus 2 times 49. Right? Which, I don't know, what is that? 32 plus 72 plus 98. 104, 202? I think 202. Yeah, 202. Okay. Yeah, exactly. I need this to, I want this to stop being curvy. Okay. And then here, this is, oh wow, this is very interesting. Yeah, this is like programming. Okay. So watch what happens here. So first of all, they tell us to start at the second index. Okay. So this is going to be x, and I is 2 in this case. So this is x2 minus what I is, which is just 2. And then we're going to go to the next one, which is I is equal to 3. So now that's x sub 3 minus the I, which is 3. X sub 2 was 6, so this is 6 minus 2, which is 4. Then x sub 3 here was 7. 7 minus 3 is 4. So adding these up, you get 8. Trepanist has a stats question. If the failure rate for a month is 10%, what would the failure rate be for 3 months? I feel like it should be multiplied to 10%. It's 10% cubed is what it is. I think, right? Failure rate. Yeah, it's not a 30% failure rate. I don't think you add the percentages. Well, it depends. Yeah, I think it's 0.1 cubed. Right, 10%, 10%. You have to also think about math-wise, right? Because then what would the failure rate be for 12 months? 120%? You can't have more than 100% failure rate. I think Trepanist, they're asking you the what's the chance of there being a failure after 3 months? Is that what they're saying? Or what's the chance of there being a failure every month for 3 months? I think that's how that works. Wouldn't the number 12 show up there? 90 days versus 30 days. It's just that's a weird question. Sorry, what? One second. I'm a little. One second. Failure rate. Contraceptive effectiveness rates. Like what, dude? What? This is what I get for fucking. Why is birth control the first thing when I pull up failure rate? That's not gonna help me. Okay, great. I was hoping for like a stats answer. Statistics, failure rate. Okay, there goes. Okay, here we go. Failure rate is defined as the total number of failures within a population divided by the total time expended by that population. Oh, okay. Oh, then in that case, it's just still 10%. Right? They're 12 months to a year. I think the failure rate is still just 10% because you're increasing the number of failures, Trepanist, but then you're also increasing the number, the amount of time. I believe. It's like the probability. Yeah, where's just like. Then there's the hazard rate. Wow, there's all these fun ones. What? A lot of cool things here. Failures per unit of time is lambda. The mean time between failures is 1 over lambda. Yeah. Okay. Yeah, it's not actually a probability because it can exceed 1. Oh, that's interesting. Ah, okay, okay. Yeah, the extra time does lead to more chance of failure. But I think they both go up proportionally, right? But I feel like yeah, they say the total number of failures divided by the total amount of time. And assuming that it's, independent, right, of each other. Like, having a failure doesn't mean that your chance of failure happening again increases. That should also just triple. The number of failures would triple. Yeah, I think that's what it is. Okay, one sec. But Falcon, let me give back to you. Does this make sense so far? Does this part make sense here? Could we make this into a tree figure? I don't know about a tree figure, maybe. Make sense? Does this make sense? Like if we do this one, do you understand how this works? This becomes x1, y1 plus x2, y2 plus x3, y3. Yep, great. Yeah, cool. And then this becomes x2. Oh, interesting. They're separate. Okay, this is x2 plus x3 times, and then this is y1 squared plus y2 squared. This one's a little trickier, Falcon, how this one is. That's what this becomes. Got it? Cool.
That's dope.
Nice, Falcon. Let me see. What else do I got? Got a lot of questions today. Ooh, 15 viewers in the chat. What's up, guys? If you guys don't know already, yeah, I'm sure the bot's saying a bunch of times, but yeah, we have a Discord. That's how all the students are submitting their questions that I go through. We do this 3 times a week. If you ever want to know the schedule, here's the schedule. So tomorrow's will be an hour later, starting at 4 o'clock Pacific, and then Wednesday starts at 5. But if you have any questions, math, science, whatever, we go through them in the hour and a half we have. What is it? What is a tree figure here? Wait, I like this question, the failure rate one. So the first month there is a 0.30 chance for failure.
Did you get a chance showing the proof?
Not yet, not yet. One sec. Don Does Math says, I think it's 10%. You can roll the dice as many times as you want, but the chance of getting a 6 on your next roll is still 1/6. Yeah, exactly, Don, right? Yeah, I feel like it doesn't matter how many months, because I think it's independent, right? The failure rate's independent of the different months. If it's 10% for 1 month, then it's 10% for the second month. It's 10% for the third month. But it's still 10%. It's weird. They talk about this on the wiki page about how you're not really supposed to think of failure rate as a probability, though. They say that's kind of a weird thing. It's not actually a probability because it can exceed 1. It should be independent. Yeah, but then how can the probability exceed 1? How can the failure rate exceed 1, I guess? Yeah. All right. Hypatia, let me find your question. Not your question. Your write-up. I really like your write-up that you gave us. 'Cause I got 10 minutes before I got to go to my next student. Where is it? Hypatia. Yes. This was it. Beautiful. Very nice proof. Yeah, you're welcome, Trapanis. All right, let's see. Yeah, this was... Suppose the coefficients... the probability of something falling with 1/10. What's the probability of it falling within 3 months? Yeah, I like that. Yeah, I feel like that's a better one. Yeah, you need some more context to clarify the... Yeah. I think that's what goes into... That's what goes into this. Where we talk about, I guess, the survival function. You know, how long can something last before it fails? Or, I guess, yeah. Yeah. It's pretty cool. And then the hazard function. That's cool. Okay. Our periodic, but that for some whole number m equals 0, we have a to the m plus n is equal to a to the n. Aha. Okay. I like this. So m is like the period here, Hypatia, right? So for instance, if I have like a1 plus a2 plus a3, and then it's plus... And then
I think big M is the period. I
it's
don't
a
quite
periodicity.
remember.
It's like this. Yeah, it's like how many how many elements I
The
have.
period is big M.
Yeah, big M. Big M is a period. Yeah. Prove that it converges absolutely for x is less than 1, and that this convergence is equal to this. Okay. So we said let a be the maximum along the values of this, which allows us to make the bound. Okay, I like this. So you're setting a bound on it first. So n equals 0 to infinity, okay, is less than... Is this to just get rid of any of the negatives? Is that what we say?
It's the definition of absolute convergence.
Absolute
If
convergence.
it's
I like
not
that.
Otherwise, it's not. Like, it can be pathological.
Got you. Okay, cool. All right. I agree with this. Ooh, where do we get the 1 minus x here, though? Where does this come from, Hypatia? How do we go from here to here? Oh, is this the... This is just the definition of a geometric series. This is a definition of a geometric series. Yeah. Okay, good. Cool. Yes, I agree with that. Okay. Then one may derive the latter identity from. Okay. So 1 minus x to the m times f of x is f of x minus f of x. Okay. What did we say f of x was? F of x was a geometric series, though. Okay, cool. Okay.
This thing is supposed to hold for all x.
Okay.
Like within the domain.
Got you.
Of course. But...
Got you. Okay. So then... Okay, and then, yes, so we said that this... Yes, okay. Minus x to them. Okay, great. Aha, and then this is a property of... Oh, I see. This is clever, Hypatia. You're basically going to show that once we divide this out, that we get this. Oh, that's very cool. I like that. That's cool.
This is exactly one last time on your stream when you first showed this thing. I mentioned in a sentence or two, like you are going to extract the
results
out of it. Like, like the XM out of it, because you can combine the terms, one period into one single term. But I wrote it in a more clear manner.
I like this.
So that
and I like this because, we said a to the n is equal to a to the n plus m. That's the periodicity. That's where this comes from.
I find writing it out without skipping the steps actually helps when teaching.
No, it does.
People
it does. I like this.
Can't follow that.
So you leave this, and then this. Aha. Okay. You have it go to 1 period, and then you say, okay, from that period to infinity. This is the same thing. Okay. Got you. And then n equals m. Are you rebounding this? How's this working?
I'm just changing the variable because starting from n to infinity with a and x n is the same thing as starting from 0 to infinity, but you add the m.
N plus m. I like that. That's very cool.
It's to cancel these two out. Do you see it?
These two go away. Yeah. Oh, wow. That's cool. Okay, so then we're left with this. So...
And now since the denominator, like the thing you want to divide by, is not 0, you can just get the identity.
Okay, 1 sec. And so then I had this, right? Okay, I had 1 minus x to the m times f of x was equal to this. Very cool. Okay, so then I just divide this out, and then you get the whole thing. Wow, that's super cool, Hypatia. I like that.
Mention that. I don't know. It doesn't really specify it, but this is also exactly the analytic continuation of that function passed to singularity.
I think that the real clever part here, Hypatia, that I probably wouldn't have gotten is setting up this. So you kind of knew what the answer of what we wanted it to be is, right? So you took this over here, and I think this is the intuition that I lack in doing formal math proofs.
That identity is a part of the problem. Like
exactly. Yeah. You're looking at the problem and you're like, okay, let me just show this is equal to this. That's super cool.
That's a straightforward step. If you want to actually come up with that identity, you need to play around with it a little bit more. But since it's given, it's not that hard anymore.
Right. Wow. That's super cool. I like that.
Because you can already see there is an x to the m term there, which suggests that you want to combine periods together, or another way to think about it. It's the thing I wrote here.
Yeah, no, I like this. This is beautiful because this teaches a lot about reindexing, summation form, which is similar to what you were doing, Falcon. It's a lot harder than this, but it's the same concepts. You're using these different indices to rewrite sigma summation things, which even it was funny. Ethan at the beginning was like, "Why do we have this sideways m thing?" He says, "Who came up with this?" I was like, "The Greeks did. It's the Greeks. Sigma." Very cool. Okay, awesome. I appreciate that, Hypatia. I gotta go pretty soon here, so thank you everyone for coming to office hours. Had an amazing time going through all your questions today. Wow, super cool. I appreciate everyone's. I learned a lot of stuff here. I learned about hazard rate, and I learned how to reindex things. And wow, yeah, it's cool. I learned with you guys, which I'm super appreciative for. All right, our next stream is going to be tomorrow. That's going to be an hour later, so that starts at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. Come on by, join the Discord if you haven't yet. That's the best way for you to get your questions in. And so we know which ones to help out. What I'm going to do now is, are any of the math streamers? No, none of the math streamers are streaming? Oh, what? Come on, guys. I got to tell people they got to start streaming. Usually I would raid another math streamer right now, but none of them are streaming right now. Anyways, whatever. It's okay. I know tomorrow or Wednesday they'll probably be streaming. I'm making an attempt to show up to every stream. I appreciate that. Well, yeah. Let me help you. Help me help you type thing. Yeah. Falcon, yeah. Anytime you have something like this that doesn't make sense, please submit it and whatnot. If we run out of time, there's usually another math streamer that's streaming something, and then I'll have us raid their channel, and you can ask them as well. We had a lot of cool people in this chat. Penn Center, Ian Stuckey, Edith the Pie Eye, Don Does Math. Yeah, all these guys are great, and they run their own math streams where they also help people out. And so I appreciate all their input and stuff. Yeah. He's a little bit later in the evening. Yeah, I know it's either Danny or I guess Ian Stuckey would usually be streaming, but I think they're on vacation right now, right? Yeah. Yeah. See, what's this? Does this bot thing work everywhere, Penn Center? Your bot, this Enigma bot? I think I need to talk to Enigma about getting it enabled in my stream. But anyways, okay, I gotta go teach some more. But good to see you guys. I will see you again tomorrow. Come on by. Have a wonderful rest of the Monday. Enjoy the beginning of the week. And yeah, I was up late too. Cool. All right. Peace.